Welcome to this tutorial about DynaSim. We will explore how it is possible to build two different simulation scenarios sharing part of the network and other elements. The goal is to compare the base situation with a future layout to assess the impact of it on the traffic. What you can see now in the main window of DynaSim is the base network. The green part of the network will be interested by the changes, while the blue one will remain the same. Before building the new network scenario, we are going to organize the layers to be used in the scenarios. For now, let's click here and you can see that there are only two layers, one called net base and one called control base. They contain all the elements of the network and all the elements that regulate the behavior of the traffic. We are now going to add some additional layer. Net proposal, control proposal, net shared, and count shared. Let's press on apply and quit. Now I need to assign the correct layers to the correct network scenario. Starting from the base network, I need to add as layers counts shared and net shared. Now I'm going to add an additional network scenario. I will call it proposal network, and it will have counts shared, net shared, control proposal, and network proposal. I can also change the map assigned to this network scenario, so I will select proposal from the list. Let's press add, apply, and let's now visualize the base network as before. Currently, all the trajectory of the base network are saved into net base layer. I need to move the blue trajectories into the shared layers. To do this, I'm going to select multiple trajectories using the left button and the control key. Now let's press the right button, select change layer, and I can select net shared as layer. Let's press OK to confirm. After this, we can simply move from one network scenario to the other one using this list. And you can load the correct background using this button. We can now start with the modeling of the roundabout. The first step is to do the approaches to the roundabout, as we have already done. Then we need to design the roundabout, and at least one support needs to be placed for every entry and exit point. Let's now start with the drawing of the roundabout. Let's select support. Let's put here the first support. It will be saved into net proposal, and I will use as a simulated width 2 meters and as lane spacing 4 meters. Using this configuration, we'll avoid the two tracks to go on parallel on the two lanes. Let's press OK. Let's design the roundabout. We are now going to put all the supports we need over the roundabout. And then I can adjust the position of the supports and the shape of the trajectory. And now, for instance, I want to connect the roundabouts with this simple exit lane. I just need to design a trajectory from the internal support to the support of the approaches. The same for the entry point. Maybe I can just move a little bit this one this way and do this. Because my roundabout has two lanes, if I have an entry or an exit approach with two lanes, the design is a bit different. So let's start with the entry point. I need to add a support here, and then to design a trajectory from the external support of the approach to the external support of the roundabout. Now I can just press extend and it will be automatically designed. For the exit, I need to put two consecutive supports here, one here and one here. This one will be connected to the external support of the approach and this one to the internal support of the approach. So for now, let's start drawing the trajectory between the two external supports and then press roundabout two lanes exit. This trajectory is automatically completed by the software. After the drawing of the roundabout, we need to put all the priority rules that are required to manage the behavior into the roundabout. First, we are going to put some priority rules at the approaches. For example, we need one priority rule here, stopping the vehicles coming from this approach that want to join the roundabout. We will put a first marker in the position of the stop and a second marker on the conflicting trajectory. Then we need to edit the priority rule and to change the length of zone of visualization and put this value equal to around 25. We also need to put counter priority as null. You can see the visibility area as blue lines on the roundabout. We also need to put another priority rule for the internal lane. And in this case, we have two conflicting points. One is here and the other one is here. Let's check the parameter of this second priority rule. As you can see, everything is correct. These priority rules allow to manage the behavior of the vehicles entering the roundabout. We also need to manage the behavior of the vehicles that are already inside the roundabout. To do this, we need to use an additional element that is called strict stop. The first marker will stop vehicles into the roundabout when a vehicle is detected in the visibility area. For example, we need to put a strict stop here if a vehicle is detected in this area, or a vehicle is detected here. We need to edit this strict stop. As length of zone of visualization, we will use a very small value, like 4 meters, and the counter priority will be put on yes. It is really important that the visibility area is not overlapping with the priority rule, otherwise the model will stuck. Let's put a second strict top for this direction. We will stop the vehicles into the roundabout if any vehicle is detected in this area. If you go here, you can see that this is the length of visualization area. Because our roundabout is composed of 2 lanes, it is necessary to insert some rules to manage the lane changes. These rules allow to specify the starting and the extreme point for the lane changes. We will specify 2 lane change distribution for the roundabout, one general for all the vehicles and one specific for vehicles going on at the first approach and that need to stay on the external lane when entering the roundabout. In order to create additional lane changes, we need to click on Multi-Lane Lane Change Distribution. Let's add a first distribution and let's call it General. And let's use as profiles 25, 25 and 0. Let's press back and now we will create an additional lane change distribution for the vehicles exiting at the first approach. Add. In this case we are going to use 50, 50 and 100. Apply. Now we can use this lane change distribution into our model. For the approaches that has only one lane, we can use just the distribution called General. And let's go to save this one in Net Proposal. Let's do the same for the other direction. For the east and west approach, we need to have a general distribution that will influence all the vehicles coming from this approach. And we also need to use a lane change distribution constrained by direction. We will apply turning as lane change distribution, and we need to specify which vehicle are interested by this distribution, putting a marker in the destination of this vehicle, so here. Let's do the same for the other direction now. And in this case, our destination is this one. Now that the entire network has been designed, we need to input flows into the model. In this case, we are going to use counts and not to import origin and destination matrix. DynaSim will use counts information to estimate the flows into the network. Because the flows are shared between the base network and the proposal network, we are going to put the marker in the shared area, so over the blue trajectories. To put markers, we are going to press this button here and to draw the marker over the trajectory. There are two different types of counts. One is directional counts, in which we can define how many vehicles are going from which trajectory into which trajectory, like in this case. Or we can define just how many vehicles are passing through this marker without defining the final destination. Once we have put all the markers into the model, let's right click. We are going to save all of these markers into count share layer. We can define a value for the tolerance, and it will be used in the estimation process. And now we can specify, for instance, how many vehicles are going from west to north. Let's put, for example, 250. How many vehicles are going straight? 600. And how many vehicles are going south? 250. Let's now press OK. And for example, we can put just accounts with total value here. In this case, I don't have specified the final destination, so I just have a section value to define, and I'm going to put, for example, 150. And according to all the markers defined into the model, DynaSim will assign this flow. After the definition of the counts, we can now define our flow scenario. Let's create an IM-based scenario, and the type has to be estimation. Press Add and configure. Here we need to select which is the scenario network that we want to use for the flow estimation. We can also specify additional parameters like the number of iterations. We can put it equal to 999, the theta value, and the maximum path and the spread. These three parameters allow the different spreading of the vehicles over multiple paths, if they exist, between the same origin and destination. Let's press apply, and now we are going to create an additional flow scenario called AM proposal. Let's press add, configure, and here we need to select a different network, so the proposal network. Apply and quit. Now we can start with the simulation. It is easy to note that using this menu on the top, we can simply go across all the different network scenarios in this way. In order to run the simulation, let's first use this button in which we can edit the simulation scenario. So we are going to simulate on parallel the network-based scenario and the proposal scenario. So the first combination is based on base network, AM base as flow scenario, and signal as signal scenario. Let's press add, and then let's go and create the proposal network, AM proposal, and none as signal scenario. For now, everything is not computed yet, so let's go on with calculate. Let's press simulation, multi-run, and let's do the same for the other scenario. The two scenarios are now running in parallel, so we need to wait for the simulation to finish. Okay, first one is finished, perfect. Then we can go back and press quit. In the menu window, we can just directly see the animation derived from the computation. And as you can see, we can check for problem and error in the model, cues, strange behavior, and so on. and we can quickly move to the proposal network, selecting the right combination, and just watch the other simulation. In this way, we can easily compare the behavior of the two models, and we can assess the impact of any layout using data collectors to extract results as delays, journey times, flows, and so on. The possibility to run in parallel two different scenarios allows to save time, because using layer it is possible to move and to share objects among different scenarios, as we did. And it is possible to minimize errors when a change is required on elements that are shared over different scenarios. Thank you for watching this tutorial, and please get in touch if you have any question or if you want additional information about DynaSim.